Hello everyone, myself Hans. Today we are going to solve the problem of Jacobians from topic differential calculus. Here in the question, if x is equal to sine theta under root of 1 minus c square sin square phi and y is equal to cos theta and cos phi, then show that del of x comma y upon del of theta comma phi is equal to minus of sin phi bracket and 1 minus of c square into cos square theta plus of c square cos square phi upon under root of 1 minus c square sin square phi. This is the important problem from Jacobians. Let's solve the problem. Given x is equal to, here this is sin theta into under root of 1 minus of c square sin square phi, and y is equal to cos theta and into cos phi, and we have to find the value of del of x comma y upon del of theta comma phi, and we have to show that this function. So del of x comma y upon del of theta comma phi is given by del x upon del theta and del y upon del theta, and this is given by del x upon del phi and del y upon del phi, and we have to calculate the value of del x upon del theta from given values and del x upon del phi from these values x, and del y upon del theta from the value of y, and del y upon del phi we can also find the given value of y. First we have to find the del x upon del theta. Del x upon del theta is given by differentiating x is equal to sin theta under root of 1 minus of c square sin square phi, taking phi as a constant, differentiating with respect to theta. This gives, first we have to take under root of 1 minus of c square sin square phi taking constant and differentiating sin theta with respect to theta. This gives cos theta, and under root of 1 minus of c square sin square phi is taking constant, and further we have to find del x upon del phi. Del x upon del phi, this is given by the value of x differentiating with respect to phi taking sin theta as a constant. So we have to write here sin theta is constant and differentiating under root of 1 minus of c square sin square phi with respect to phi. When we have to differentiating under root of x, we get 1 upon 2 root x. So we have to write here 1 upon 2 root under root of 1 minus of c square sin square phi, and again in the under root 1 minus of c square sin square phi differentiating with respect to phi, this gives minus of c square is constant, and sin square phi differentiating with respect to phi, this gives 2 sin phi, and again sin phi differentiating with respect to phi, this gives cos phi. And from here we have to cancel out the terms, 2 to 2 is cancel out, then we have to get del x upon del phi is given by, here this is minus of c square and this is sin theta, and here this is sin phi into cos phi upon under root of 1 minus of c square sin square phi, and further we have to calculate del y upon del theta. Del y upon del theta, this is given by y is equal to cos theta into cos phi, differentiating with respect to theta taking phi is a constant. So we have to taking cos phi as a constant and differentiating cos theta with respect to theta, this gives minus of sin theta and into cos phi. Again we have to find the value of del y upon del phi. Del y upon del phi, the value of y is equal to cos theta into cos phi, differentiating with respect to phi taking cos theta as a constant. So we have to differentiating cos phi with respect to phi, this gives minus of sin phi. So we have to write here cos theta into sin phi, And further we have to putting the value of this determinant. So we have to write here, this is given by del of x comma y upon del of theta comma phi. This is del, and we have to put in here the value del x upon del theta. We have to calculate here, this is cos theta into under root of 1 minus of c square sin square phi, and del y upon del theta is given by minus of sin theta into cos phi, and we have to put the del x upon del theta, del x upon del phi. This is given by, once again we have to rough del y upon del theta, we have to put in here. So we have to write here once again del x upon del theta, the value this is given by minus of c square, once again minus of c square into sin theta into sin phi into cos phi, and upon here is under root of 1 minus of c square into sin square phi, and further we have to find the value of del y upon del phi. This is given by del y upon del phi is given by, we have to writing here, this is minus of cos theta, once again we have to writing here, this is minus of cos theta into sin phi, and we have to solving the given determinant, once again we have to expanding, this gives del of x comma y upon del of theta comma phi, and we have to expand solving the given determinant, cross multiplication with this gives minus of cos square theta, cos theta into cos theta, and here is sin phi is also present, and into of under root of 1 minus of c square sin square phi, and when we have to cross multiplication with these sides, here minus is already present, then minus minus is plus, and when we have to multiply this side we take a minus, so we have to write here minus of c square here sin theta, and here is also sin theta, this gives sin square theta, and here is sin phi, here is cos phi, here is also cos phi, so we have to write here cos square phi and sin phi into sin phi upon under root of 1 minus of c square sin square phi. Further we have to solve the given determinant. We can write here once again. We have to solving here, taking LCM, this gives on multiplication with under root of 1 minus of c square sin square phi, this gives minus of cos square theta, and here is sin theta, and sin theta, once again we have to sin theta, not sin theta, here is sin phi, sorry, we have to writing mistake, this is sin phi, this is sin phi, this is sin phi, and we have to multiplying under root of 1 minus of c square sin square phi with under root of 1 minus of c square sin square phi, this gives 1 minus of c square sin square phi, and here is minus of c square sin square sin square theta, and this is cos square phi and into sin phi upon under root of 1 minus of c square sin square phi, and we have to show that here del of x comma y upon del of theta comma phi is equal to minus of sin phi in the bracket 1 minus of c square cos square theta plus c square cos square phi upon under root of 1 minus of c square sin square phi. Further we have to simplify. We can also write this is del of x comma y upon del of theta comma phi is given by, here we have to take from numerator sin minus of sin phi is taking common, minus of sin phi is taking common, this gives cos square theta, and here is 1 minus of c square into sin square phi, and here is plus of c square sin square theta into cos square phi. We have to taking sin phi is taking common from numerator, and remaining is upon under root of 1 minus of c square into sin square phi. And further we have to also simplify. We can also simplify. This is written as, once again we have to writing here, this is minus of sin phi in the bracket. We can also write these terms sin square phi. First we have to multiply. This is given by cos square theta, and here is minus of c square sin square phi into cos square theta, and here is plus of c square sin square theta into cos square phi upon under root of 1 minus of c square sin square phi. This is given by del of x comma y upon del of theta comma phi. Further we can also simplify. Sin square phi is written as 1 minus of cos square phi from trigonometry. So we have to write here once again. We have to write in, this is minus of sin phi bracket here, this is given by cos square theta minus of c square, and we can write here sin square phi is written as 1 minus cos square phi. Sin square phi is written as 1 minus of cos square phi, and here is also present cos square theta, and plus of c square sin square theta into cos square phi, and for upon under root of 1 minus of c square into sin square phi. And further we can also simplify. We can also write, we can writing here, this is minus of sin phi in the bracket, this is given by cos square theta, and here we have to minus multiply with this term, this gives minus of c square, and here is minus of c square cos square theta, here is cos square theta is also present, cos square theta, and we have to minus c square cos square theta multiply with minus of cos square phi is written as plus of c square cos square phi into cos square theta, and here is plus of c square sin square theta into cos square phi is already present, and upon here is under root of 1 minus of c square sin square phi. And further from here we can take a common from here. Once again we have to write in, this is minus of sin phi, and in the bracket from here we have to take in cos square theta is taking common, this is written as cos square theta is taking common, this gives here remaining is 1, and here is c square, this gives When we have to take common from cos square theta here, this gives 1 minus of c square, and here is plus of, and from here we have to take common, once again, c square cos square phi. We have to take in common c square cos square phi, and this gives here is cos square theta, and here is remaining plus of sin square theta. And we know that from trigonometry cos square theta plus sin square theta is 1, and here is upon under root of 1 minus of c square sin square phi. And from trigonometry we know that cos square theta plus sin square theta is 1. So we have to put here 1 and we get the required result. So we have to write in here, this is minus of sin phi, in the bracket here this gives cos square theta 1 minus of c square, and here is we have to put in here cos square theta plus sin square theta is 1, so we have to get here plus of c square cos square phi upon under root of 1 minus of c square sin square phi. This is the required solution of the given problem. Thank you class, and thank you for watching. This is an important problem for UPSC as well as all university examination from topic Jacobians. Thank you class, and thank you for watching.